origin of natural rubber. Before giant tires are made in factories, everything starts far away from machines inside nature. Natural rubber does not come from oil or metal. It comes from trees. Natural rubber is produced on large rubber plantations. These plantations are filled with rubber trees that are grown for many years. A rubber tree usually needs several years to mature before it can be used for rubber production. Once the tree is mature, workers begin a process called tapping. A thin, careful cut is made on the outer bark of the tree. This cut does not damage the tree permanently. It allows a white liquid to slowly flow out. This white liquid is called latex. Latex looks like milk, but it is actually the raw form of natural rubber. The latex flows slowly from the cut and drips into small cups attached to the tree. Workers collect this latex from thousands of trees every day. The collected latex is then transported to nearby processing centers. At this stage, the latex is still liquid and contains water and natural impurities. Inside the processing center, the latex is first filtered. This removes dirt, bark particles, and other unwanted materials. After filtering, the water content is reduced. Next, the latex is transformed from liquid into solid form. This process is called coagulation. During coagulation, the liquid latex thickens and turns into soft solid rubber. The solid rubber is then pressed into flat sheets or large blocks. After pressing, the rubber is dried and cured. These sheets or blocks are easier to handle and transport. Drying removes remaining moisture and improves strength. Once fully dried, the rubber is compressed into dense bales. These bales are strong, compact, and easy to ship over long distances. Finally, the rubber bales are wrapped and sealed for protection. They are now ready to be transported to tire factories, where the industrial manufacturing process begins. Raw materials arrival after natural rubber is prepared and shipped. It arrives at the tire factory along with other essential materials. This is where the industrial journey truly begins. Natural rubber reaches the factory in the form of compressed solid blocks or tightly packed bales. These bales are usually wrapped to protect the rubber from dust, moisture, and damage during transport. Along with natural rubber, synthetic rubber also arrives at the facility. Synthetic rubber is produced separately using chemical processes and is delivered in standardized pallets or sealed industrial containers. Both natural and synthetic rubber are required to achieve the strength and flexibility needed for giant tires. Another critical material is carbon black. It arrives in large bulk bags or is stored directly in tall vertical silos. Carbon black gives tires their black color and greatly improves durability and resistance to wear. Silica may also arrive in similar bulk form to enhance performance. Chemical additives such as oils, sulfur, and accelerators are delivered in clearly labeled drums or sacks. These chemicals play an important role later during mixing and curing. For structural strength, steel wire arrives at the factory wound tightly on heavy metal reels. Textile cords made from materials like nylon or polyester also arrive in large rolls. These components help reinforce the tire from the inside. Cranes, forklifts, and conveyor systems are used to unload all materials safely and efficiently. Once unloaded, every shipment is visually inspected for damage, contamination, or moisture. Each batch is then weighed and logged into the factory system. This ensures accurate tracking and quality control throughout production. Finally, all raw materials are sorted and moved into climate-controlled storage areas where they are kept in optimal condition until the manufacturing process begins. So all raw materials are ready. The tire manufacturing process moves into the rubber mixing and compounding stage. This step is critical because it determines the strength, flexibility, and durability of the final tire. The process begins with natural and synthetic rubber blocks being cut into smaller pieces. These pieces are fed into large internal industrial mixers. These mixers are powerful machines designed to handle extreme loads and high temperatures. Inside the mixer, carbon black and silica are added. These materials strengthen the rubber and improve resistance to heat, wear, and cracking. Without these additives, the rubber would be too weak for heavy industrial use. Next, oils and plasticizers are introduced into the mixture. These substances improve flexibility and make the rubber easier to shape. During later stages, they also help control how the rubber behaves under pressure. Chemical additives such as sulfur and accelerators are then added. These chemicals play a key role in the curing process that will happen later, allowing the rubber to harden properly. The mixers operate at very high temperatures and pressure. Massive rotating blades knead and blend the materials together. This intense mixing ensures that every ingredient is evenly distributed throughout the rubber. Automated control systems carefully manage the exact ratios of each material. Temperature and mixing time are constantly monitored to maintain consistency and quality. As mixing continues, the rubber gradually becomes smooth, uniform, and fully blended. Once the compound reaches the required properties, it is discharged from the mixer. The finished rubber compound exits the machine as hot slabs or continuous strips. These strips are temporarily cooled and prepared for the next stage of tire production. After the rubber compound is properly mixed, it moves to the sheet forming stage, also known as calendering. This stage transforms the hot rubber into smooth, controlled sheets that will later become tire components. The hot rubber compound is fed continuously into large calendering machines. These machines are built with massive steel rollers designed to handle thick, high-temperature rubber. As the rubber enters the machine, It passes between multiple heavy rotating rollers. These rollers apply strong pressure to the rubber, compressing and stretching it evenly. This process ensures the rubber spreads smoothly without weak spots. The thickness of the rubber sheet is precisely controlled by adjusting the distance between the rollers. Even small changes in spacing can affect the final tire performance. So this step is carefully regulated. As the rubber moves through the rollers, its surface is smoothed and flattened. This creates a uniform sheet with consistent texture and strength. When required, steel cords or textile fabric layers are introduced during this process. These reinforcement materials are placed between rubber layers. As the rollers continue to rotate, the rubber bonds tightly around the steel or fabric, locking the reinforcement inside. The machine produces continuous rubber sheets at a controlled speed. Sensors monitor thickness, alignment, and surface quality throughout the process. Once formed, the rubber sheets pass through cooling rollers or air cooling systems. Cooling stabilizes the rubber and prepares it for precise cutting. Finally, the finished sheets are guided forward to the next stage, where they will be shaped into individual tire components. After the rubber sheets are formed, the manufacturing process moves to tire component preparation. In this stage, the tire is broken down into its main parts: tread, sidewalls, and beads. Each part is made separately with high precision. First, large rubber sheets are cut into precise sizes and shapes. Automated cutting machines ensure that every piece matches exact specifications. Accuracy at this stage is very important for tire balance and safety. Next, the tread rubber is prepared. Rubber is pushed through extrusion machines that shape it into long strips. During this process, deep groove patterns are molded into the tread. These patterns are designed to provide grip, stability, and durability. The tread strips are then cut to exact tire dimensions. Sidewall markings, textures, and identification details are also formed at this stage. Each strip must match the size of the tire it is made for, especially in giant industrial tires where small errors can cause big problems. High-strength steel wires are wound into circular bead rings. Another critical component is the bead. These rings give the tire its structural grip on the wheel rim. The bead rings are tightly wrapped and reinforced, then fully coated with rubber. This rubber coating helps the bead bond securely with the rest of the tire during assembly. At the same time, sidewall rubber is prepared on separate lines. Sidewall sections are shaped, trimmed, and smoothed to achieve a clean and strong finish. Each component, tread, sidewall, and beads, is produced in its own dedicated production line. Once ready, all components are carefully organized, stacked, and transferred to the tire building area for final assembly. At this stage, all prepared components come together to form the tire. This process is known as tire building, where the tire is assembled layer by layer with high precision. The process begins with the tire building machine drum. The drum is thoroughly cleaned and carefully calibrated to ensure accurate dimensions. This drum will act as the base shape for the tire. First, The inner liner rubber is placed onto the rotating drum. The inner liner forms the airtight layer inside the tire and must be applied smoothly without wrinkles. Next, fabric pie layers are wrapped around the inner liner. These fabric layers provide flexibility and basic structure. They are carefully aligned to ensure even strength throughout the tire. After the fabric layers, steel cord belts are positioned. These steel belts add strength and help the tire maintain its shape under heavy loads and high pressure. Bead rings are then placed precisely on both sides of the drum. These beads are critical because they allow the tire to grip the wheel securely. Once positioned, the beads are locked firmly into place. Sidewall components are applied over the structure. The sidewalls protect the internal layers and give the tire its final outer shape. Finally, the tread strip is wrapped evenly around the tire body. This step completes the outer surface of the tire. Once all layers are in place, they are aligned and pressed together. The assembled tire, known as a green tire, is shaped into its final form before curing. Once the tire is fully assembled, it is known as a green tire. Before it can be permanently shaped and hardened, it must pass through a detailed pre-curing inspection stage. The green tire is carefully transferred from the building machine to a dedicated inspection station. At this point, the tire is still soft and flexible, so handling is done with care. First, inspectors check the overall shape and symmetry of the tire. The tire must be evenly formed on all sides. Any imbalance at this stage can cause serious problems later. Next, the alignment of fabric layers and steel cord belts is verified. These internal layers must be positioned correctly to ensure strength and stability during use. Bead positioning is then inspected. The beads must be seated properly and securely, as they are responsible for holding the tire firmly on the wheel rim. The tire surface is closely examined for visible defects such as wrinkles, air bubbles, folds, or small cuts. Even minor surface issues can weaken the tire after curing. Tire dimensions are measured and compared against exact specifications. Weight and uniformity are also checked to ensure consistency across production. If any defect or misalignment is found, the tire is immediately rejected and removed from the production line. Only green tires that meet all quality standards are approved and cleared to move forward to the curing stage. After passing inspection, the green tire moves to one of the most important stages in tire manufacturing, molding and vulcanization. This is the stage where the tire gains its final shape, strength. And durability. The green tire is carefully positioned inside a heavy steel curing mold. This mold is designed with precise patterns that will form the tread and sidewall details of the tire. Once the tire is placed correctly, the two halves of the mold close tightly around it. Inside the tire, an internal bladder expands. This bladder applies pressure from the inside, pushing the rubber firmly against the mold walls. High heat is then applied through the mold surfaces. At the same time, strong pressure is maintained from both inside and outside the tire. This combination of heat and pressure triggers a chemical reaction inside the rubber. This reaction is called vulcanization. During vulcanization, rubber molecules chemically bond together. This process transforms the soft, flexible green tire into a strong, elastic, and durable product. As the rubber is pressed against the mold, the tread pattern and sidewall markings are permanently formed. Every groove, logo, and texture is created during this stage. The tire remains in the mold for a carefully controlled time period. Temperature and pressure are continuously monitored to ensure proper curing. Once the curing cycle is complete, the mold opens. The fully cured tire is removed, now solid, durable, and ready for the next stage of production. After curing, the tires are extremely hot and must be cooled carefully. Cooling is not just about lowering temperature. It is essential for tire strength, shape, and long-term performance. Cured tires are moved from the curing machines to dedicated cooling zones. This transfer is done carefully to avoid deforming the tire while it is still warm. Tires are placed on racks or moved along conveyors. These systems allow air to circulate evenly around the tire surface. In some factories, natural airflow is enough. In others, forced air systems are used to control cooling speed. As cooling begins, internal heat slowly dissipates from the tire. Rapid cooling is avoided because it can create internal stress or weaken the rubber. During this stage, the rubber structure stabilizes after vulcanization. The chemical bonds formed during curing settle into their final state, giving the tire consistent strength and elasticity. Material stresses created by heat and pressure are gradually released. This helps prevent future cracking, warping, or uneven wear. As the tire cools, its shape and dimensions fully settle. This ensures the tire maintains correct roundness and balance. Tires remain undisturbed for a controlled period of time. Once fully stabilized, they are ready to move forward to inspection and testing stages. Stage 9, quality inspection and testing. Once the tires are fully cooled and stabilized, they move into the quality inspection and testing stage. This is one of the most critical steps in the entire manufacturing process. Tires enter a series of automated and manual inspection stations. At first, the overall surface of each tire is visually examined. Inspectors and cameras check for visible defects such as cuts, cracks, bubbles, or deformities. Advanced testing methods are used to examine the tire internally. X-ray machines or internal scanning systems look inside the tire without cutting it open. These scans verify that steel belts and internal layers are correctly positioned and free from defects. After internal inspection, the tire is tested for balance and uniformity. Specialized machines spin the tire to detect any imbalance or uneven distribution of material. Proper balance is essential for smooth performance and safety. The tire's diameter, width, and weight are then measured with high precision. These measurements must match strict specifications for the tire to perform correctly under heavy loads. Air pressure and strength resistance tests follow. These tests ensure the tire can handle extreme pressure and stress during real-world use. All inspection and test data is recorded in the factory system. Any tire that fails to meet standards is immediately identified and separated. Only approved tires move forward to the final processing stages. Stage 10, finishing, marking and trimming. After passing quality tests, the tire moves into the finishing stage. This step focuses on appearance identification and preparing the tire for final approval. First, any excess rubber left from the molding process is carefully trimmed. Small rubber edges, known as mold flash, are removed using cutting and trimming tools. This gives the tire a clean and precise shape. Next, the tire surface is brushed or cleaned. This removes dust, residue, or loose rubber particles. A clean surface is important for clear markings and a professional finish. The sidewalls are then smoothed to ensure a uniform and consistent appearance. Any uneven areas are corrected so the tire looks balanced and well-formed. Brand logos and manufacturer markings are applied to the sidewalls. These markings identify the company that produced the tire and are permanently embedded or printed. Technical information is added next. Tire size, load rating, speed rating, and other specifications are clearly marked. This information helps users choose the correct tire for their machines. Identification and tracking codes are also printed. These codes allow the tire to be tracked throughout distribution and help with quality control and recalls if needed. After marking, the tire surface is visually checked again. Inspectors look for cosmetic defects such as scratches, uneven markings, or surface imperfection. Minor cosmetic issues are corrected when possible. Once finishing is complete, the tires are cleaned and prepared to move into the final inspection stage. Stage 11. Final inspection. Before the tires are packaged and shipped, they go through the final inspection stage. This step ensures that every tire meets strict quality and safety standards. The tires pass through the final inspection station, where trained inspectors and automated systems review each unit carefully. The overall appearance of the tire is checked first. Inspectors look for any visible issues that may have been missed earlier. Brand markings and identification labels are then verified. These markings must be clear, correct, and properly placed on the tire. Any missing or incorrect information can lead to rejection. Next, the tire's shape and roundness are confirmed. The tire must maintain proper symmetry to ensure smooth performance during use. The surface finish is also checked to make sure it is clean and consistent. To maintain quality consistency, random tires are selected for additional retesting. These samples undergo further checks to confirm that production standards are being met. After all checks are complete, a final quality approval is assigned. Tires that do not meet the required standards are rejected and removed from the production line. Only tires that fully pass final inspection are clear to move forward to the packaging and shipping stage. Stage 12, packaging, storage and shipment. After passing final inspection, the approved tires move to the packaging area. This is the last stage inside the factory before the tires are delivered to customers. First, the tires are stacked, wrapped, or banded together depending on their size and destination. This helps protect them during handling and transport. Protective covers or plastic films are then applied. These covers prevent scratches, dirt and damage while the tires are moved or stored. Next, shipping labels and barcodes are attached to each tire or tire group. These labels contain important information such as size, model, batch number, and destination. The tires are then grouped by size, type, and shipping location. This makes loading faster and reduces the chance of errors. Packaged tires are moved into large warehouse zones. Inside the warehouse, inventory is tracked and organized using digital systems to ensure accurate stock control. When it is time for delivery, tires are loaded onto trucks, trailers, or shipping containers using forklifts and cranes. Finally, the shipments are dispatched to distributors, dealers, or customers, completing the journey from raw material to finished giant tire.